Oh, I gotta share my screen, don't I? Is it sharing both screens? Like, is it sharing both screens right now?
Here, I'll see.
I was just showing you which one is 1 and 2.
Okay.
I don't think you should.
So for this, remote, can you see my screen?
Yep.
Yes, we can.
I can't hear anybody.
Yes, thanks.
Why does this always happen? Where are the remote students? Can one of the remotes speak up so we can hear? We can hear you.
Sure.
We can hear you. Can you hear us?
Oh, she
Can you
says it.
Testing.
We can see your screen and hear you loud and clear.
Oh, that's what it is. Yep.
That's the same kind of issue with some of my Bluetooth products. So you got to remove it.
So easier.
Remote, can you hear me now?
Yes, can you hear us?
Yeah, we can hear you.
Loud and clear.
What is it?
Where's the aux cable?
He put it somewhere. Please.
Some kind of user event, somebody-
Remote, can you hear me?
Yes, we can hear you.
We're gonna go ahead and do that.
And see your screen.
Sweet. All right, we're gonna go ahead and get started. So today we're gonna talk about test-driven development. And test-driven development is essentially a process of writing tests before you're actually writing any code. A lot of companies do test-driven development because there's essentially have to write every single code, like every single function. You're supposed to test it before it actually goes into production. It goes into like the real world. You want to make sure it's handling all the edge cases and everything before you push that code to the production, because otherwise you're going to get errors, your users are going to hate you for it, and everything like that. So essentially, test-driven development is a software development process that relies on the repetition of very short, agile development cycles. And kind of right here, it's essentially you're going to write a test case, write your function that makes sure that test case passes, and then you're going to write another test case to handle another edge case. Then you're going to continue writing your method until the entire function essentially meets the requirements of the whatever instructions you want that function or method to perform. So yeah, as a developer, you're forced to think through your program as opposed to like start writing code and then all of a sudden like you're passing in random data that your function wasn't initially intended to like support. So if you pass in those, can you still see our screen? So for like the factorial, you're assuming that the user is always going to be passing in a number. But what if they like pass in a string or pass in null or don't pass in anything? So the whole point is to like write your test case for that specific instance, and then like write your actual function. So each language has their own different testing frameworks, plugins, or libraries that they'll use. So they're called unit tests. So you're going to test a single case, which is a unit, essentially. Python is actually pretty good. They've got like a built-in library called unit test. It's very convenient, and that's what we're going to be using today. And then in JavaScript, there's going to be multiple. We're going to be utilizing multiple libraries. One's Jest, that's what we're going to start out with. There's Jasmine, there's Mocha. Once we go on to React, there's Enzyme. There's all those kinds of libraries for doing unit tests.
So testing's really important. A lot of developers and places where people are lazy and they kind of do sloppier work, they'll test after they write code, and they might not test all of their code. And what happens is, when you're developing a website, you'll go back to your browser, see if it works, and then you'll write some code, and then go back to your browser, see if it works. And that's manually testing. You're manually testing it, and you're not going to remember to test everything every time you change something. You're not going to be able to actually have the time to test everything. So you'll test what you think you should, but if you have test-driven development, you already have those tests written before you write the code, and all the code will work together as your app grows. Because even on the scale you guys make apps, you'll still have bugs. But more and more bugs the bigger your app gets. And without tests, you can't catch them.
Awesome. Thank you. Yeah, so today we're gonna walk through testing this FizzBuzz problem, and FizzBuzz is a very common threshold problem that developers will see or be tested on to just test it to see that if you guys are actually a developer. So you might see it in coding challenges. If you guys apply to jobs, might send you some coding challenges, and FizzBuzz might be one of them. It's like a very baseline. If you can't solve this, then you really can't really think logically and develop code. So we're gonna walk through doing FizzBuzz. So write a program that prints numbers from 1 to 100, but for the multiples of 3, print fizz, and instead of the number, and for the, for multiples of 3, print fizz, and in multiples of 5, print buzz, but for numbers which are multiples of both 3 and 5, print FizzBuzz. So before we even write a piece of code, like write a method or a function, we're gonna write a test file, which have you guys seen the spec files so far? So yeah, we're gonna go ahead and get started. So right here, I've just got an example TDD file. I'm gonna actually delete that. So I'm in my folder, test-driven development folder. You guys don't need to make a separate folder for test-driven development. It should just go right next in the same folder as your current file. So RM. So touch, I'm gonna do a fizz. What was it? Just FizzBuzz. Spec.py. So this is going to be my spec file for testing this method called FizzBuzz. So we're going to just copy and paste this in here right now. So we're going to have to import unit test, which is a built-in Python library. We're going to have, once we have a FizzBuzz file, once we actually have the FizzBuzz file, we're going to import the FizzBuzz function or method from that file. That's what's going here. But for right now, a test case, this is kind of like the overall architecture of setting up a testing or a test case for the function FizzBuzz. So it's a class, capital letter, just FizzBuzz. I don't know if that's necessarily required or anything like that, but it doesn't have to correlate to the name of the function, but we kind of do want to know what test case corresponds to what method that you're testing. We're going to encapsulate that in the unit test, which is calling this unit test library .test case. And our test case will go here. And at the very end, like this is not even encapsulated within the class, but this just goes at the very end of the file. So let's continue. What do we know about our method and our desired output? We know that it's return a list. So in our initial requirements, it's going to print a number between 5 or print numbers in between numbers 1 and 100. For multiples of 3, it's going to print fizz. For multiples of 5, it's going to print buzz. And for multiples of 3 and 5, it's going to be print fizz buzz. So for this initial or this test case, we want our method to return a list, and in that list, it's going to have numbers 1 to 100, and in the index of where there's 3 and 5, it's going to, or in the index where it's a multiple of 3, it's going to input fizz in there, and a multiple of 5 is going to put buzz, and then for the indexes of like 3 and 5, it's going to print fizz buzz. So it's got to return a list. It should return a list of 100 elements. And the elements in the list should look like this. Those are the 3 things. So let's start writing our test cases. Should I copy this? Oh. Oh. Did I not paste it there? So each test case that tests a single element or a single instance is a method. And how do we define a method in Python? Yep. And we want to name the method kind of like what is it testing. So test returns an array. Test returns a specific value, and that value will go in here. We'll encapsulate that with self to because when we're using class statements, we'll use the self because it refers to this specific instance of the class. So, and we want to print, when you call fizzbuzz, the actual method, you should get an array back. And that's what's going to be printed out when you run this test case. Self, S or equal, there's a bunch of different, what is it, unit test? Like a bunch of different unit test methods. S or equals. Test cases. So yeah, there's going to be a bunch of different built-in methods in unit tests that will test like what it should return, what it won't return, stuff like that. So here we go. Here's the link, sorry. So here's like a bunch of built-in methods that you can look at or can use, like should equal, it doesn't equal, returns true, returns false, all these ones. So write a test case that returns an array. So let's create our actual Python file for fizzbuzz. Where's it? Touch fizzbuzz. Code. So how do I write a method in Python? Perfect. Fizz. And then number, like
No. That's just number. And then
cool. And then for that first test case, let's split the screen here. Test returns an array.
I don't think this was taken.
Is it not? Yeah, it doesn't say to, does it? See?
Not yet.
All right. Then how do I return in Python? If I want to return something. Return. Yep. How do I make an array? Now, let's run this file, but not the FizzBuzz file, but let's run the spec file. Okay, so ran 0 tests. Okay, is that normal? So right now we've got a good first test. You see that we get an error because we haven't run any. Okay. So I'm writing a single test case, and then I'm writing a piece of code to make sure that test case passed. But let's keep going and bring in a different test case. Do you know how to move backwards? What's that?
No.
Like
Shift tab.
Shift tab.
Shift tactical.
Yeah. Oh,
Man, tab.
yeah. I want to see something real quick. Unindented does not match any outer level. Line 8. Oh. Anybody see?
Line 8.
Should the DEF start where class does?
No.
No.
But it should start where the comment up, because it also uses comments for space. So the test score FizzBuzz should be at the same indentation level as test for FizzBuzz.
See if that works.
Now it's saying the next line where self assert that one with that comment. So self does, yeah, there you go. That's
Sweet. Thank you. There you go. Error. What is it? FizzBuzz is not defined. We got to import it. One test ran. Before up here it said like 0 tests ran. That's because this was all the way indented, or not all the way to the first line. So now we're good with that. Once this ran, it's okay. Test returns an array of 100 items. When you call FizzBuzz, you should get 100 items back. Good. So Return. Let's go back to here. Let's. How do I create an array that returns 100 items?
Array equal range 100.
And then return R. Let's run this test. Failures. Ran 2 tests. Where does it say? Test returns an array. You should get an array back.
You can. So you can make it a quick loop using a range 100 and just push items to that array.
Okay. So walk me through it.
So for whatever I in range 100, push I to array. And I forget if range is inclusive or exclusive.
Append it to array.
Append, sorry.
Sorry. Okay.
Like so.
Yep.
See if that works. Okay, awesome. Here we go. So we've got that. So the final test, ensuring that the line we get back have the correct elements in the correct indexes. So right here. Now, this is a long one. Make sure indentation is right. Does that look correct? So this is like the meat of the problem. So I'm going to be looping through an array, or I've got an array of 100. So from here, now what do? I'm iterating for I in range 100, so range 100. So I'm getting 1, so I is like essentially the index, so it's 1. How do I test if it is a
Modulus.
if? How do I do mod in Python?
I know this is still a percentage.
Percentage.
I'm on 3 is equal to 0.
No?
I would start with 15 because it's the rarest restricted case.
Oh yeah, that's
15?
Not 15.
Right.
Yeah, so
Yeah,
so
yeah, because
no, so
15
you can write that. So I'm on 3 equals 0, and I'm on 5 is equal to 0. Then this was so yeah.
Okay, in here.
Print.
So let's just let's
Will
print
it be ARR? No.
let's print I, like to see what index that is. And let's actually just run this file. Bring this up. Oh. Gotta invoke it. Zero, 15, 30, 45, 60, 75, 90. Does that look right?
Yeah.
Awesome. So yeah, why 0?
Because it's gonna always equal 0.
But
You gotta start at 1.
There we go. How do I make a range between two different?
You add another parameter to the range.
Yeah, 1 comma.
Awesome. So in here, instead of printing, I want to add it to the array. Is it FizzBuzz?
This was.
Let's print the array. No, that's not right now. Okay, next one. What should we do? Want to do it? Is it Elif? The next one we're doing 3. We're gonna append. And then else, what are we gonna do?
Else.
Append I.
Does all this make sense so far? So let's just run, let's print the array and just run the file. Oh, sweet. So our tests will determine whether or not this works. Clear here. We've got 3 tests. Test returns the correct array. It should equal when we run. So the assert equal should, so like the type of the method, when you return it, it should be a list. So the type, when this method is ran, the type of it should be a list.
So in Python, you're calling arrays and objects lists.
No, so array and list are they're the same thing. In JavaScript, we call them arrays. In Python, they're called lists. Yeah, or they're called arrays. So the difference between objects, we can get into this. When you call an object in Python, I think it refers to like a method kind of thing. I'm not 100% sure.
Dictionary.
Right, so yes. So an object in JavaScript is equivalent to a dictionary in Python. So if you're like trying to search for like what are the key value pairs of an object in Python, it might give you an OPEC answer because they don't refer to objects the same way as we do in JavaScript. So I kind of use dictionaries. If you think of a dictionary as the book, it's got the word and then the definition. You got the key and then the value. So let's run this and see if it works. I'm going to go all the way up. 2 failures. Ran 3 tests. What's that?
It doesn't include the last value for the.
Ah, so yeah. So in range, if you do like range 10, it does not include that 10. It just goes up to 9. Is that right? So let's see which ones should return a array of 100 items. We only got back 99.
Can't you do a range 1 ... 100?
Range 1 ... 100?
Yeah.
Like ... 100?
Yeah.
Let's test it out. I think you are correct. Nope.
Guess not. Maybe that's JavaScript.
one failure. What happened?
It needs to be lowercase b.
Say that?
You have an uppercase b in FizzBuzz. It needs to be lowercase.
There you go. It's importance of reading the documentation. FizzBuzz, right there. Awesome. That's test-driven development. Does anybody have any questions right now?
So we are, this is a already formulated problem with a spec that's already created for us, right?
Mm-hmm.
We're gonna have to be, are the basic elements before you input the stuff in the middle there, that go up a little bit? Where you say, where it says import, the from, class, everything there, and the last one on the bottom, the if statement on the bottom, that's going to pretty much be the same.
Yes, so like this is a good beginning architecture to set up your test specs for Python. What other questions? Nothing? Do you have any?
I would say do this yourself too.
Yeah.
And write tests for, if you want practice, you can write tests for things you've already written. But yeah. You start using unit tests on your algorithms going forward.
So yeah, and when you pull down all the repos, they already have a test spec file in there. But the test spec file is essentially just like console logging and giving you some test cases. This is the way to actually do it. So in the real world, when you're actually writing code, when you push code to like production, depending on the DevOps and how their DevOps is set up, when you push code automatically to like the main repository of the application, it'll run all the tests that you've written and make sure they're all passed. Or if they don't do that, most of the time, as they're pushing to production, they'll run all the tests first to make sure everything passes. If anything fails, it won't push like the application to production. So
you can find something online or find something you can import that makes failures red and success green. That will make it easier to see in your terminal.
And I think most JavaScript libraries have that visualization queue. Visualization different. So if you haven't already, go ahead today. You guys can take like a 10-minute break, come back and finish up your Python challenges, and then move on to these 8, and then start writing test cases in them. And then here, when you get to JavaScript, we're going to use Jest. Jest is a testing framework for JavaScript. And so you're going to have to use NPM.
Start with the Python.
Yeah, start with the Python. It's easier to get started. And then you guys can move on to the Jest. And today you guys are going to be doing pair programming. Same with you, remote. We're going to be pair programming today.
Find someone you haven't paired with.
So right now you guys can take a 10-minute break. Be back at, what is it? It's like 10:55. Get with your partners and finish up the rest of the Python or any of the challenges that you haven't finished, and then move on to test cases.
Okay. The test casing and JavaScript, is there also
How do I-